Okay, here's another question from Matrix Operations Competency 2. Solve a given matrix for unknown variables. Okay. Solve a given matrix equation for unknown variables. So here I have A, which has an unknown variable x, and here I have B, which has no unknown variables. And I'm asking you to solve the following equation if possible. Z times A plus Y times B equals minus 310, 15 minus 2. And here I should say this is for x, y, z, because these are the unknowns. So see if you can find x, y, z that solve this equation with this value of A and this matrix B. So go ahead and try it and pause the video, and then you can look at my solution. All right, so let's think about this. We've got a linear combination of two 2x2 matrices gives me another 2x2 matrix. Now, in order for this matrix equation to hold, all four entries must match. Those four entries give me four equations. So let me just think about this as a system of four equations. Four equations and three unknowns, x, y, z. So I should be able to phrase this in terms of a augmented matrix. Okay, so let's go ahead and do this. All right, so what I want to do is set up these four equations, and then I'll solve them using my conventional methods. Okay, so if I look at the 1, 1 entry, what do I get? Well, I have z times a. The 1, 1 entry of a is minus 5, so I have minus 5z. Then plus yb, the entry of b is 6, so I have plus 6y. It's equal to minus 3. Okay. Then let's look at the 1, 2 entry. Okay. The 1, 2 entry is first row, second column. So first row, second column, I get 2 here for the a. So I have z times 2, 2 times z. 1, 2 entry of b is 2, so I have y times 2, so that's 2 times y. All right, and that's equal to the 1, 2 entry of the result, which is 10. All right, now let's look at the 2, 1 entry. 2, 1 entry, well, 2, 1 entry of a is 1, 1 times z. 2, 1 entry of b is 6, plus 6 times y, and that's equal to 15. Okay. All right, now the 2, 2 entry, then I'm going to have here x, so I have zx, xz. Okay. Then here I have yb is minus 4b, minus 4y, is equal to minus 2. All right, so I got four equations here. And four equations I can arrange as a matrix equation. I know I can do that. So I have my z column and my y column, and then I have my constant column. So my augmented matrix just becomes let's see, here I have minus 5, 6, 2, 2, 1, 6, and x minus 4. And then here I have, let's see, this is minus 2, 15, 10, and minus 3. All right, now you can use symbolic math to reduce this because you've got an unknown here, x. But there's another way you can do this. Notice that here you've already got three equations for z and y. That should be enough to determine z and y if they exist. So why don't I just deal with the first three equations, and then I can take care of x later after I found z and y. Now if you think about what we're doing, we're solving for x, y, and z. If I can solve for z and y, then I can find x later. There are other ways of doing this, but that's one way. All right, so in that case, I'll solve for z and y. And then that's just, I'm just going to get minus 5, 6 minus 3, 2, 2, 10, 1, 6, 15. And I want to take the REF of that. Okay. So you can use your favorite software method and get the REF. I'm going to go ahead and use SymPy. So I want to enter these rows in, minus 5, 6, minus 3. So my first row here is minus 5, 6, minus 3. And my second row, 2, 2, 10. My third row, 1, 6, 15. All right, let's see how this works. It's going to take a second, so I'm going to pause it. All right, so I got the result down here. The result is right here. So I'm going to screen clip it and bring it into my OneNote window. All right, and let me put that back in the form that I want. So that's going to be equal to, let's see, gives me 103, then 012, and 000. All right, so what does that tell me? Remember, the first column was my z column, second column was my y column, and this is my constant column. So that's giving me z equals 3, y equals 2. Okay. Now z equals 3, y equals 2 works for 3 out of 4 of these equations. Then I just need to solve the last one for x. Now what does this last equation mean? This one says, this last equation says zx minus 4y equals minus 2. But z is 3, so I have 3x minus 4 times y, which is minus 8, equals minus 2. So I'm getting 3x minus 8 equals minus 2. So let me write that down. 3x minus 8 equals minus 2. Then you just go ahead and solve that, bring the 8 to the other side. That gives me x equals 2. Okay, so that's my total expression. Z equals 3, y equals 2, and x equals 2. And that's what was asked for, right? That's the solution. And that does verify all 4 equations, right? Because the matrix showed that y and z satisfy the first 3, and then I chose x to satisfy the 4th one. So those are all satisfied.